Welcome to The Explainer. Today, we're going to dive into a pretty fascinating new paper that proposes a totally radical redesign for AI data centers. We're talking about one that's designed to work with its environment, not against it. All right, first, I want you to picture this. A massive AI facility, just plopped down right in the middle of a hot, dry desert. This thing is powerful enough to run a small city, a 200-megawatt beast just crunching data for the next generation of AI. Okay, now imagine that same desert facility does all of this using absolutely zero fresh, drinkable water for cooling. I mean, not a single drop. And get this, it's built to be carbon neutral. That means it operates without needing a single kilogram of new copper pulled from a mine. You might be thinking, how is that even possible? Well, that's really the heart of the issue, isn't it? As AI scales up, the strain on our resources is just becoming immense. But this new conceptual paper argues that the answer is a hard no. And, it proposes a really revolutionary solution to break this cycle. Okay, so let's get into it. To really truly appreciate how elegant this design is, we first have to understand the sheer scale of the problem it's trying to solve. The explosive and, let's be honest, almost insatiable growth of AI is putting an incredible strain on three key resources. We're talking massive demands on our power grids, a huge thirst for fresh water to keep things cool, and a supply of copper for all the components that's getting tighter and tighter. I mean, this path, it just isn't sustainable. So what's the alternative? What if, instead of being this massive consumer, a data center could actually become a self-contained circular system, one that generates some of its own most critical resources? And at the core of this whole concept is something the authors call the heat, water, metal data loop. It's an integrated system where the waste from one part of the process, things like heat or salty water, becomes the essential fuel for another part. Absolutely nothing is wasted. Now this, right here, is where the model just gets completely flipped on its head. A standard data center, it takes in precious resources like fresh water and new copper, and it spits out waste. This new design, it takes in waste, salty brine, old electronics, and it produces not only data, but also fresh water and recycled copper. It's a system that literally transforms environmental liabilities into its own core resources. So let's break down how this thing actually works. We'll start with the first piece of the puzzle. How does this system cool itself down in a scorching hot desert without using any fresh water? Right, so instead of these giant water-guzzling evaporative towers, this design uses a really clever combination of technologies. It all starts with a closed loop of salt water, or brine. The heat is then moved to these special radiative panels on the building skin that literally beam thermal radiation out into the cold of deep space. This is incredibly efficient, especially in a desert where you have those clear night skies. It's a perfect window to the vacuum of space. It's basically like having a radiator to the entire universe. So the key takeaway here, the crucial point, is this. By combining all these techniques, the design aims to completely, 100%, eliminate the need for fresh water for cooling. And that is an absolute game changer for building powerful AI infrastructure in the very places that have tons of sun but very little water. Now for the second really brilliant piece of this closed loop, how it becomes copper neutral. It doesn't just reduce its need for new copper, it's actually designed to create its own supply, right on site. This whole system follows a four-step cycle. First, you've got intake. The system collects two waste streams, the concentrated brine from its own cooling loop and local e-waste. Second, it uses a process called eutectic freeze crystallization, which is, basically a super specialized freezing technique, to separate pure ice from a slurry of salts and metals. In the third step, these special bioadsorbent gels, which act like tiny targeted sponges, selectively capture copper. And finally, that purified ice is returned to the cooling loop, and the recovered copper is reused on site. It's literally urban mining. Now, I know this might all sound a little bit like science fiction, but the paper doesn't just stop with the concept. It actually lays out a very concrete roadmap to make this a reality within the next decade. The plan is super methodical and it's de-risked. It kicks off in 2026 by just testing the core cooling tech on a single rack. From there, it scales up to a larger block that brings in the resource recovery part. And by 2030, the goal is to have a full-scale 200-megawatt AI campus operating on these exact principles. Of course, the authors are realistic about the hurdles. And the biggest one, the high initial cost to build it. But they've actually built economic strategies right into the design. That staged rollout helps manage the investment. And the system is designed to create new revenue streams by selling its byproducts, things like low-grade heat for nearby greenhouses or the valuable metals it recovers. So, this is about way more than just a blueprint for a single futuristic data center. The implications of thinking this way are actually much, much bigger. This whole concept is really a fundamental reframing of how we approach industrial design. It goes to show that massive infrastructure doesn't have to be a drain on the environment. It can actually be designed to be regenerative, to solve resource problems instead of just creating them. What we're really looking at here is a model for a true circular economy in action. You've got technology, which produces heat and waste, and it's integrated with ecology and the economy. The waste streams aren't just managed, they become the raw materials for creating value, completely closing the loop on water, metals, and energy. And that really leaves us with a pretty powerful final thought. If we can apply this kind of integrated, circular thinking to something as complex and as energy-hungry as an AI mega data center, what other systems in our world are just sitting there, waiting to be transformed? What other waste can become a resource?